So in this third video, we are going to see the centroid of some very common geometries, which we usually encounter in this particular topic. So first geometry is rectangle. So rectangle has a dimension in which you can say the length of the rectangle is dimension b and height of the rectangle is dimension h. As I told you, since rectangle is symmetric about both x and y axis, the centroid will lie at the half distance in x direction. So if the length was b, it will be b by 2 in x direction, and if the height is h, it will be h by 2. Now it's not only about the geometry dimension. How this particular geometry is placed in the figure also plays a significant role. So if I am going to flip this geometry, like now this becomes h. Now h is my new breadth and uh, b is my new height. So in this scenario, now you see the dimensions have changed. This is my x direction and this is my y direction. So now for x bar, the value will be h by 2, and for y bar, the value will be b by 2, which is completely opposite of what we have studied before. So it's not only about the geometry, it's about how it is placed. So similarly, if I have a square of sides A and A. So its x bar and y bar position will be, again you can see we have an axis of symmetricity. It will be A by 2 and it will be A by 2. Now for an isosceles triangle or an equilateral triangle also. Let me draw an equilateral triangle. You see, if the base is L and the altitude is H, then the image in the x direction, the centroid in the x direction can be found out by L by 2. But as I told you in the previous video also, since a triangle does not have a symmetricity about y-axis, it is definitely not going to lie at the middle point. So this value in altitude direction actually is given by h by 3. Here you can see h by 3 from the bottom surface, or from the top. If the entire height is h and this height is from this dimension is h by 3, then the same point from the top face will be your 2h by 3, h minus h by 3, which is 2h by 3. But if the same geometry, this isosceles triangle or this equilateral triangle, is placed like this in your figure, now remember this is my x direction, this is my y direction, and since I have flipped it, I'm going to keep the dimensions same. This is my L and this is my H. So now since the direction has changed, you can see that the location x bar will be given as h by 3 from this extreme left point, and y bar as L by 2, which is completely opposite of what when the triangle was placed. So just take a look, remember how this geometry is placed. Just don't remember, you will need to remember these values, but don't remember like it is a uniform value, it is going to be constant. No, this value is going to change once you change the direction of the geometry. Okay, not dimension, direction or orientation. You change the orientation, the location of x and y with respect to the reference axis is going to change. So I have a right angle triangle, and remember, for a right angle triangle, this x-axis and y-axis will be both h by 3 and b by 3 from the base. So from this side in the y direction, it will be h by 3, and from it is showing b by 3 in this particular image, it will be here. From the right hand side, it will be b by 3 because the dimension is b. But if I am taking this as a reference axis, as we have seen in the last video, so what I am going to do, remember the entire length is b, dimension is b. If from the left side this dimension is b by 3, then from the right hand side it will be b minus b by 3, that is equal to 2b by 3. So because in a right angle triangle, we cannot have an axis of symmetricity. There is no way that you can fold this sheet, fold this geometry in any way that the top part is coincident with the bottom part or the right part is coincident with the left part. So remember, always remember this is, so if my right angle triangle is going to be placed like this, what is going to happen? Suppose this is my right angle triangle and this altitude, I have flipped it. So this has become B and this has become H. So from the extreme left side, this in X direction, the centroid will be H by 3. Or from the bottom side, this X bar is equal to H by 3 and Y bar is equal to B by 3 from base. And from top side, it will be X bar is equal to from the right hand side, it will be X bar is equal to 2H by 3 and Y bar will be 2B by 3 when seen from the top surface. Now for a circular area, the centroid always passes through the center. So that is why the location is given as 0, because it is assuming the reference axis to be passing through the centroid of or center of the geometry. So that is why this dimension is 0. What if I take reference axis as the extreme edge, or let us draw this as a tangent. We take them as a tangent to this circle in y direction and x direction. So now you will have to measure this distance from the reference axis. So remember, this distance is nothing but r, radius, and this distance is also r, radius. So if the reference axis is at the center, distance will be 0. If the reference axis is any of the extreme points on the periphery of the circle, it will be radius r and radius r. Then the next common geometry we'll encounter is a quarter circle and a semicircle. But let's talk about semicircle first. So here in this semicircle, we can see that I have an axis of symmetricity in x direction. Means if I'm going to fold the right hand side, it will completely coincide the left hand side. So that is why for if you are assuming the reference axis passing through the centroids, then this distance will be 0. But if you are taking this distance as extreme side, left side or right side, this distance is going to be r. And in the y direction, this value is given as 4r by 3 pi. Now remember, this value is not constant, that for a semicircle the y bar is going to be 4r by 3 pi. No. If your semicircle is placed like this, then remember, now your x and y I have changed. This is my y, this is my x. Now in y direction, the centroid, if my reference axis is this, the centroid will be r. But in x direction, now this centroid will be 4r by 3 pi. So this location, actually, this value is actually from the base, from the flat side. So remember this, from the flat side, this will be 4r by 3 pi. So if you have a geometry like this, suppose, and you always take the reference axis here, then what will be the location of this centroid? Remember, the entire distance is r and this particular section is only 4r by 3 pi. Then this distance is going to be r minus 4r by 3 pi. And this value, and once you have understood this, remember, for a quarter circle, both the x and y values, y bar values are your 4r by 3 pi. So I have taken this image from the Wikipedia Centroid section, and thanks them for providing this wonderful image. So remember, if for a quarter circle is changed like this, and then you are asked to find out the location of centroid from the left side and the bottom side. So from the flat side, it was 4r by 3 pi. So from the edge side, it will be r minus 4r by 3 pi. And from the bottom side, it is going to be 4r by 3 pi. So this is how we remember, this location is always from this flat side. It is not from this curve side, it is always from the flat side. In the meantime, I found this wonderful website on which you can play with to find out the centroid, play with different triangles. And this uh, website is going to give you the centroid, location of the centroid of a triangle based on its dimension. So play with this is playground for finding out the centroid of a triangle. Go try it. You will love this. You might love this website. So see you guys in the other video where we'll be discussing about finding out the centroid of a composite geometry. Okay.